This problem wants us to solve for n given a series of fractions. N minus 2 over n plus 2 equals 4 over n squared plus 2n minus 3n plus 2 over n plus 2. The challenge here is that the denominators of these fractions are not all the same, so we'll have to take some steps in order to make them look alike. We begin by factoring all of the denominators wherever possible. In this problem, only the second fraction has a denominator that can be factored. There's a greatest common factor of n, so we have n plus 2 left over. Now we'll take a look at each one of these three fractions and ask, what's missing in the denominator? For the first fraction, we need to include an n in the denominator, which means we also need to multiply in the numerator to keep that fraction in balance. Likewise, the third fraction is missing an n in the denominator, so we'll multiply top and bottom by n as well. We'll distribute these terms so that in the first fraction we have n squared minus 2n in the numerator, and in the third fraction we get 3n squared plus 2n. Now the denominators match, so we can combine these two fractions on the right-hand side of the equation. Since we have a negative sign in front of that second fraction, we need to make sure that we change the sign of both of those terms, so it's 4 minus 3n squared minus 2n over the common denominator. Now, since the denominators match, we can basically ignore them and focus entirely on the numerators and solve. Since we have an n squared term, we want to move all of the variables to the left side of the equation and set this result equal to 0. We can factor out a 4, leaving us with an n squared minus 1 that can also be factored since it's a difference of squares. Now we take each factor and turn it into its own little problem, n plus 1 equals 0 and n minus 1 equals 0. These are easily solved as n equals negative 1 and n equals positive 1, so we have the two answers to this problem.